In this video, we are going to answer 3 questions on projectiles. So mixed exercise 6.01 is on projectiles A-level applied maths, Year 2. Question 1. A particle is projected from a point A with a speed of u at an angle of elevation theta above the horizontal and moves freely under gravity. When it has moved a horizontal distance of x, its vertical height above the point of projection is y. Show that y is equal to x tan theta minus gx squared over 2u squared times 1 plus tan squared theta. First of all, we need to draw a sketch of the situation. So this is a horizontal and the particle is projected with speed u at an angle theta. So the path will be something like this. We need to resolve u into its vertical component and horizontal component as follows. So the horizontal component is u cos theta and the vertical component is u sin theta. So at this point, particle would have moved x horizontally and y vertically as stated in the question. So we can represent this point here as xy on the path. I'm going to use vectors to answer this question. If you prefer breaking it down into horizontal components and vertical components, that's fine. I'm going to use the Sievert equation. S is equals to ut plus half a t squared. But I'm going to use the vector form of that. So I know u in vector form will be u cos theta, that's a horizontal component, and u sin theta, that's a vertical component. It's meters per second. A, which is also a vector, will be equals to 0 minus g. Because I'm taking upward direction to be positive and downward direction to be negative. And because gravity always acts downwards, it will be negative. And that's why this one is minus 9g. So therefore, S will be xy. I can now go ahead and use the vector form of this Sievert equation, which will be S is equals to u t plus half a t squared. If I do my substitution, I'm going to get xy is equals to u cos theta, u sin theta, all of that times t, plus half 0 minus g times t squared. If I simplify this side of the equation, I'm going to get xy is equals to ut cos theta and then ut sin theta minus half gt squared. For the horizontal component, we'll have x is equal to ut cos theta. This implies that t is equals to x over u cos theta. And the vertical component will be y is equal to ut sin theta minus half gt squared. I'll go and substitute this in place of t in the second equation here. So if I do that, I'm going to get y is equals to u x over u cos theta times sin theta minus g over 2. Then I have my t squared, that will be all that, u cos theta squared. The next step is to simplify this equation that we've got here. And you can see that this and that can be cancelled. And so I'll be left with y is equal to x sine theta over cos theta minus gx squared over 2u squared cos squared theta. But sine theta over cos theta is equal to tan theta. So I can replace sine theta over cos theta by tan theta. And so this simplifies to y is equal to x tan theta. And I'm going to rewrite this term in a different way as follows. G x squared over 2u squared times 1 over cos squared theta. But 1 over cos theta is equal to sec theta. So it means that 1 over cos squared theta is equal to sec squared theta. So I'm going to rewrite this equation and replace this with sec squared theta. So if I do that, I'm going to get y is equal to x tan theta minus gx squared over 2u squared sec squared theta. Now I can rewrite this equation and replace this using trig identities. And the trig identity I'm going to use is sec squared theta is equal to 1 plus tan squared theta. And so this equation can now be written as y is equal to x tan theta minus gx squared over 2u squared brackets 1 plus tan squared theta. And as you can see, this is the equation that we are required to show. Question 2. A particle is projected from a point A with speed 40.6 meters per second at an angle of elevation of 30 degrees. The particle moves freely under gravity. Find the length of time for which the particle is 18 meters or more above air. So we'll do our sketch again. So this is the horizontal, and the speed of projection is 40.6. The angle of projection is 30. So the particle will follow a path like that. I'm going to use vectors to solve this question. So I'll need to resolve the initial velocity into its horizontal and vertical components as follows. So the horizontal component is 40.6 cos 30. And the vertical component is 40.6 sin 30. Now point A is somewhere here. And I need to draw a line which is 80 meters above this point. And so we draw the line. We get that. And like we said, it's 80 meters above point A, the horizontal. So we need to find the time for which this particle was above this line. And that would be when it was moving from here all the way to this point here. So our initial velocity u will be u equals to 40.6 cos 30, 40.6 sin 30 meters per second. And the particle is moving freely under gravity. And so the acceleration will be 0 minus 9.8. And this is because we are taking upward motion to be positive and downward motion to be negative. And since gravity acts downward all the time, that's why we have minus 9.8 here. And this will be meters per second squared. The time is what we're looking for. So I'm going to use the vector form of the Silbert equation S equals to ut plus half at squared. So that will be S is equals to ut plus half at squared. So we're going to do our substitution. And for S, that will be xy equal to 40.6 cos 30, 40.6 sine 30, all of that times t, plus half bracket 0 minus 9.8 t squared. If I simplify this, I'm going to get xy is equals to 20.3 t root 3 for the horizontal and 20.3 t minus 4.9 t squared for the vertical. So when y is 18 meters, I will have 18 is equal to 20.3 t minus 4.9 t squared. If you rearrange this equation to make the coefficient of t squared positive, you end up with 4.9 t squared minus 20.3 t plus 18 equals to 0. Now we have a quadratic equation in t. This is where you can use your Casio calculator to solve for the values of t. And if you do not have the Casio calculator, you can do it by using the quadratic formula, which is given by minus b plus or minus square root of b squared minus 4ac over 2a. So I'm going to use that to get the values of t. So in this equation, the a is 4.9, the b is minus 20.3, and the c is 18. So doing my substitution, I'm going to get t is equal to 20.3 plus or minus square root of 20.3 squared minus 4 times 4.9 times 18, all of that over 2 times 4.9. If I put this in my calculator, or if you use your Casio calculator, you're going to get two values. The first one will be t is equals to 20 over 7. And the second one will be t is equals to 9 over 7. And these are the times that the particle was here and there. We can see that because this is the smaller value, this is the time that it was here, and the time that it was here is 20 over 7. The question is asking for the length of time for which the particle is 80 meters or above, 80 meters or more above A. So that means you're going to subtract this from that. So if I do that, the length of time required will be 20 over 7 minus 9 over 7, which will be equals to 11 over 7 seconds. And that will be 1.57 seconds. And this is the time required. So this is question 2. Question 3. A particle is projected from a point A with position vector 25j meters with respect to the fixed origin O. The velocity of projection is 6ui plus 4uj meters per second. The particle moves freely under gravity, passing through a point B, which has position vector lambda I plus 15j meters, where lambda is a constant, before reaching the point C on the x-axis, as shown in the diagram. The particle takes 5 seconds to move from A to B. Find A, the value of u, B, the value of lambda, and C, the angle, the velocity of P mixed with the x-axis as it reaches C. So we're going to use silver to solve these questions. So for A, u is given by 6u, 4u, and the time is 5 seconds. With respect to A, this particle is 10 meters below A, and that means S will be given by lambda minus 10, where lambda is the distance from here to this point as given by this vector here. The acceleration due to gravity is given by 0 minus 9.8. So using our Sylvert equation, S is equals to u t plus half at squared. We can do our substitution and get lambda minus 10 is equal to 6u, 4u times 5 plus half bracket 0 minus 9.8 times 25, which is t squared. So simplifying this will give lambda minus 10 is equal to 30u, and then 20u minus 122.5, and that will be 0.5 times minus 9.8 times 25. So for the vertical component, I can use a vertical component to solve for u as follows. Minus 10 is equal to 20u minus 122.5. Rearranging will give you 20u is equals to 112.5. And finally, solving will give u is equal to 112.5 over 20, which will be 45 over 8, and that is also 5.625 meters per second. And that's u. For B, I'm going to use the horizontal component, which is given by lambda is equal to 30u, which is equal to 30 times 45 over 8. And that will be equals to 675 over 4. And finally, lambda is therefore equal to 168.75 meters. And that's the value for lambda. For C, we are required to find the angle the velocity of P makes with the x-axis as it reaches C. We are going to get a situation like this. So as you see, it's going to be, it will have a direction going that way, and that direction will make an angle of alpha with the horizontal. Now, this direction here has components horizontally, that way, and vertically, that way. So we've got one here and vertically that way. Now, because there's no gravity acting horizontally, the horizontal component of the velocity will remain 6u. So this will be 6u. But the vertical component will change, and let's call that v. Now, because this angle here is alternate to this angle, this angle here will also be alpha. So we need to find v, and then we can use tan to find this angle alpha, which will be the same as this, and which is the required angle. So we need to find v, and to find v, I'm going to use Sylvert equation again. This time, I'm going to use v squared is equals to u squared plus 2as. In this case, this u is the vertical component of the initial velocity, which is 4u. So I'm going to replace this with 4u. And so if I do that, I'm going to get v squared is equals to 4u all squared plus 2as. But 4u is equals to 4 times 48 is equals to 4 times 45 over 8. And that will be 45 over 2. So I can now do my substitution, and I will get v squared is equals to 45 over 2 squared plus 2 times minus 9.8 times minus 25. And this is minus 25 because with respect to A, when the particle reaches here, its vertical component will be minus 25. Now we can solve for V. I'm going to get v squared is equals to 3,925 over 4. This implies that v will be equal to the square root of 3,925 over 4. And so v becomes 31.6. So now I've got v to be 31.6. So tan alpha is equals to v over 6u. So I need to find 6u. I've got v now, I need to find 6u. 6u equals to 6 times 45 over 8. If I evaluate that, I'm going to get 33.75. So now I can go ahead and find my angle. And so tan alpha is equals to 31.6, which is a v over here, divided by 33.75. So alpha equals to tan inverse of 31.6 over 33.75, and that gives me 43.1. So if you write this as 2SF, we are going to get 43 degrees, and that is the answer required for C. And with that, we come to the end of this session of questions on projectiles. Thanks again for watching, and I'll see you in the next video.